Okay, this video is a book review. Here's the book called Excitotoxins. Here's a cover-up picture of it as well by Russell Blaylock. This is Russell Blaylock. He's a neurosurgeon. He wrote this book back in 1997. It was kind of like a landmark book. And you'd ask yourself, excitotoxins, they're a super important topic. If you're interested in the brain, they're one of the most important things you can know about, but paradoxically, there's almost nothing about this taught in medical school or residency. And I told you, like 1,700-page neurology textbook from Harvard. There's only like one paragraph related to excitotoxins with seizures and another paragraph under the subject of stroke. And what Blaylock says is he thinks the whole idea of excitotoxins is heavily suppressed in his opinion because of the MSG industry. Basically, conventional medical textbooks, unless something is desired by industry, it almost always gets kept out of the textbook. Like I said, there's no mitochondrial inhibitors in the biochemistry textbook, but real quick, when I look it up, I find over 50 of them, okay? And that's kind of how it is. So I think that's why this book stood out so much. And initially, there was sort of a sense, is Blaylock exaggerating? When I first read this book many years ago, I thought, oh, he's exaggerating. And he does, he was a neurosurgeon who later retired from neurosurgery, and he worked as a nutrition doctor. And he's always recommending supplements. And I thought he was, exaggerating these supplements. I still do. I think he recommends too many supplements. But I've gone back, I've read this book like 3 times, and each time I go back to it, I'm more impressed by it. How, his father had died of Parkinson's, and he was very sad about that. And that's partly, he felt that was, the Parkinson's was related to excitotoxins, and that's partly what motivated him to study excitotoxins so much. But like I said, I go back to it, and I'm impressed by the book. I mean, he put a lot of work into it. He's actually very smart, and he clarified a lot of things that weren't previously well known. He also talked about how when the pregnant mother ingests a lot of MSG, it can have a significant negative effect on the baby's brain. Because glutamate, I'm currently reading another book about glutamate. The other book I'm reading is by Mark Mattson, and he calls it Sculptor and Destroyer, about the effect of glutamate on shaping the baby's brain development. But, sorry to distract you with that side book comment, but here's the point. It's super important. According to Mark Mattson, glutamate is over 90% of the brain neurotransmitters. Let's just call it 90% of the neurons in your brain. They're working with glutamate as an excitatory neurotransmitter, meaning it increases activation of the postsynaptic neuron. In the ballpark of about 5% is GABA. And GABA does the opposite of glutamate. It decreases neuronal activity. And then the other ones that you hear about all the time, things like dopamine, serotonin, acetylcholine, norepinephrine, they're all relatively uncommon. Off the top of my head, I don't know the exact percentage, but you could ballpark it. I'd call them all about 1%. So they're very uncommon compared with glutamate, all right? They sort of modulate glutamate neurons. And the relevance is that things that affect glutamate, monosodium glutamate means monosodium glutamate, just a sodium, it's a salt of glutamate. Okay, well anyways, in animal babies, when the mothers were exposed to this or they were exposed to it in utero, they had a tendency towards being short stature, fat, obese, partially infertile if not infertile, small testicles, small ovaries, difficulty controlling emotions like episodic anger outbursts. And so I'm saying, just look at human babies nowadays. When I was in high school, I went to a big high school. I didn't know a single person of this LGBT stuff. I never heard of it, okay? And now 20% of kids say that they're one of those things. And so what I'm saying is, look at the chemicals being exposed upon these young kids. Routinely, their mothers are eating processed food with MSG in it. Routinely, they're inhaling air that's got, AL in it. AL, the element AL, has negative effects on fertility, has an effect on baby's reproductive system. Soy is a pretty powerful thing to have a negative effect. According to Blaylock, it has a feminizing effect on male babies. Atrazine is very powerful feminizing effects. That's the one Tyrone Hayes studied, and that's the one that turns the male frogs into female frogs. Okay, the male frog in early development into female frogs. Okay, bisphenol A, let's say you have a formula can, it's going to have AL is what makes the can, and then BPA is a plastic lining on the inner part of the can, bisphenol A. strongly estrogenic, also a mitochondrial inhibitor. Okay, and then the kids are also routinely exposed to MSG. They're exposed to atrazine because what sweetens the baby formula, for example, is often high fructose corn syrup, and then not to mention that's associated with HG. So what I'm saying is this poor baby is exposed to numerous toxins and endocrine disruptors, in utero even, and then at birth with the formula if mama doesn't breastfeed. So it's not easy being a kid these days. Okay, MSG also injures the hypothalamus, the arcuate nucleus. That's the hunger center. So if you damage that, and that can also be damaged, of course, by omega-6 cooking oils. That's the work of Tetsumori Yamashima. So what I'm trying to say is, poor little babies in the modern world are exposed to a lot of brain toxins and endocrine estrogenic toxins. So, people look at some person out there, hunter-gatherer, and say, oh, those primitive people, But how are we perhaps more primitive? We expose our baby to, what is this, 1, 2, 3, 4, 5 neurotoxins, and it's actually worse than this. Soy is often processed with GP, and it's also often processed with hexane, so that would throw 2 more in there. 1, 2, 3, 4, 5, 6, 7 neurotoxins our little babies are exposed to right from the get-go during the first couple months of life, and I'm sure there's other ones too. We're just not taking the time to figure them all out at the moment. Okay, so anyways, what else? EAA is a common abbreviation for excitatory amino acids, and of course there's glutamate, we just talked about it. MSG is monosodium glutamate, the salt of glutamate. MFG is manufactured-free glutamate, and from other lectures I've learned that manufactured-free glutamate, well, I'll talk about that in the next lecture, but there's certain proteins that have a lot of glutamate in it. Soy does, gluten does, and casein, like from milk. Okay, aspartate, you get that increased exposure from aspartame, like NutraSweet, commonly used to sweeten things like diet soda pop, etc. Some of the like Crystal Light, some of these like little sweetener drinks, they can have that in them. Cysteine is often in hydrolyzed vegetable protein. That's another excitatory amino acid. So these things are all excitotoxins. They're toxic to the brain. Okay, and then cysteine in particular can cross the blood-brain barrier more readily than does MSG, but there's ways they can all get across the blood-brain barrier. I'll briefly mention that in this lecture here today. Whenever you hear extract, there's a whole bunch of different names around MSG. We're not going to get into all those today, but when you hear the word extract, you should think MSG. I won't eat anything with an extract. That's why I don't eat any cereals anymore. I don't eat any breads anymore. And people go, oh, well, Ezekiel bread, it's so good. You go in the refrigerator at Whole Foods or something. Well, look, I pulled out Ezekiel bread. I pulled out Ezekiel cereals. And, a lot of times I've seen extract word in there, so I won't touch them. I just assume that's MSG. I looked at an Ezekiel cereal in the store just recently, and there it is. It's got extract. I consider that MSG to prove it otherwise, so I won't eat anything that says that. Okay, then, there's also issues about, is MSG related to more serious diseases like, and it's not necessarily MSG, it's just other excitotoxins. Are they related to Parkinson's disease and ALS? Here's how a neuron works, okay? You got the neuron cell body up here. Here's the dendrites. They receive incoming messages, come into the neuron. If the neuron gets significantly excited, it'll send an action potential. Action potential is carried through by sodium channels beginning right here. It's called the axon hillock. They're transmitted down the axon of the neuron. Then they reach the synaptic terminal. When the action potential reaches this calcium channel here, it's a VGCC. The VGCC stands for voltage-gated calcium channel. When calcium comes into the cell and it reaches a significant concentration in the cytoplasm of the synaptic terminal here, it'll cause these neurotransmitters, these are neurotransmitter vesicles, to move to the plasma membrane of the synaptic cleft, and they will merge with it and release their neurotransmitter vesicles. Those will diffuse across the synaptic cleft. They'll bind a receptor on the postsynaptic neuron, and they will activate some sort of effect. Okay, that's standard neurotransmission in a neuron in the brain. Okay, so imagine that this is our neuron here. The calcium has come in, and now the calcium concentration got high enough. These glutamate vesicles of neurotransmitter glutamate merge with the plasma membrane. Glutamate's released across. It binds these receptors on the postsynaptic neuron. Typically, we see it binding what's called the AMPA receptor. -R is for receptor. That'll cause sodium to come into the cell and depolarize it, meaning increase its resting membrane potential closer to positive, okay? And then you've got magnesium. Magnesium actually sits in the center of the NMDA receptor for glutamate. So glutamate binds both of these receptors, the AMPA receptor to lead and sodium, and then the NMDA receptor. Once this cell has become more positively charged inside its membrane potential, that's called depolarization, then the magnesium is no longer attracted to it because it's no longer a strongly negative charge. Okay, let's say negative 65 millivolts in here, magnesium is attracted, it sits inside of the NMDA receptor. But when you become more like, negative 40, it starts becoming more positive, the magnesium just jumps out of the center of the NMDA receptor. And that's a big deal because now it allows calcium to come through into the postsynaptic cell. And in normal small amounts, this happens all day long and it's a good thing. But when there's an excessive amount of things causing increased calcium in the cytoplasm of the postsynaptic neuron, that can be bad. If you get too much calcium in here, you can start activating pathways that you don't want to activate. And that's what excitotoxicity is all about. Okay, so here's a couple more points from Blaylock. Chronic low-dose exposure to excitotoxins he thinks is potentially related to Alzheimer's disease. Increased excitotoxins can cause headaches, like Chinese restaurant syndrome is sometimes called, can cause seizures even, okay? A lot of the anti-epilepsy drugs, AEDs, are glutamate-blocking drugs. So, like, let's say I had epilepsy or someone I knew had epilepsy. One of the things you could try doing is dramatically avoiding all of these excitotoxins, avoiding anything related to causing increased excitotoxicity. So that's a whole nother topic for another day, but I'm just saying there's a rationale for it here. Okay, the guy who sort of figured out that MSG was an excitotoxin and that excitotoxins were a big deal was this John Olney, PhD, back in the 1960s. And he actually, went and made a big deal about the problems with MSG, and he got it taken out of the baby foods. It used to routinely be in baby formulas and other baby foods back in the 1960s. That means I probably ate it, without even knowing. I don't know how long my mother breastfed me. I should have asked her. She's dead now, unfortunately. Only showed that MSG caused brain damage in whatever animal he studied, in rats and mice and chickens and primates and dogs, which therefore makes it likely that it does the same thing in humans. As people started to become a little bit aware of problems with MSG, the MSG companies are real smart. They just changed its name. They put it in all kinds of, like for example, if you've got 2 or more ingredients in a food, in the second ingredient, they can put MSG and not have to tell you. Okay. Plus, they gave it all kinds of names: extract this, vegetable protein, soy protein isolate. It's in all kinds of things. You don't even know it. That's why I don't eat any processed foods, because I figure it's going to be in there and I don't want to eat this stuff. Russell Blaylock in 1997 said that the average American was eating 10 to 20 grams per day of excitotoxins. That's a lot. Some people eat much more than that. People who eat a lot of processed food. Humans concentrate glutamate in their blood more than other animals do. There's more details on glutamate and MSG than we have time to get into here, but I'm just sort of, basically letting you know you want to avoid this stuff as best you can. That's why you want to avoid processed food. Given the choice, you don't want to eat it. Okay, the brain only weighs 2% of our body weight, but it uses about 20% of our oxygen and glucose, and it can't store much energy. The astrocytes can store a little glycogen, but not that much. And they can make more mitochondria, but you really need a constant oxygen and glucose delivery feeding into the brain. But here's one of the things that's a big deal, and you want to know this. Hippocampus has a very high density of glutamate receptors. So what that means is anything that causes excitotoxicity is at increased risk to injure the hippocampus, where you form new memories. So it's a very big deal. If you destroy your hippocampus, you lose the ability to form new memories. So that's a very big deal. And this also means why the hippocampus is so vulnerable to all these problems: the hypoxia, lack of oxygen, hypoglycemia, lack of glucose, to high MSG or MFG, manufactured free glutamate, also the low magnesium. One of the things the food companies will say, MSG is not that big of a deal. It can't even get into the brain because the brain has an intact blood-brain barrier. But that's actually deceptive, because the brain has something called circumventricular organs. These are the ventricles of the brain where they contain cerebral spinal fluid. Like here's the third ventricles in this area right here. So these little organs around this third ventricle are called circumventricular organs. And they often are chemosensors. They sample the chemistry in the blood because it can affect what they do. And there's a whole bunch of these things: subfornical organ, organ of vasculosum, lamina terminalis, posterior pituitary. There's a chemosensor area postrema, also called the vomiting center, and it'll vomit if it senses you're absorbing something from your gut that's toxic. Pineal gland, which releases melatonin, to help you sleep. And here's all kinds of things that are associated with leaky blood-brain barrier or increased permeability of the blood-brain barrier. Like we said, the ones we just described, circumventriculars and these other related ones. In utero, the baby doesn't have much of a blood-brain barrier. When it's a newborn, still doesn't have much of a blood-brain barrier. Kids have less of one than adults. A high-fat meal will cause increased blood-brain barrier permeability. Things that cause leaky gut tend to cause leaky blood-brain barrier. Lack of fiber in the diet causes leaky gut. It also causes leaky blood-brain barrier. Ischemia of the brain, like all those silent strokes I talked about in other lectures. Hypertension and diabetes will injure the endothelial cells of the brain, give you a leaky blood-brain barrier, and cause hypoxia, leading to leaky blood-brain barrier. Stroke causes leaky blood-brain barrier. Traumatic brain injury causes leaky blood-brain barrier. Once you've got a leaky blood-brain barrier, the MSG and other excitotoxins have increased access to the brain tissue, the brain parenchyma. Psychiatry doing electroconvulsive therapy will increase blood-brain barrier permeability. If you had given very high doses of MSG, Blaylock thinks that might be able to sort of overwhelm the normal blood-brain barrier and even breach it and allow some excitotoxin into the brain. Okay, so anyways, that's kind of interesting. Okay, some more thoughts from Blaylock's book here. We talked about these excitotoxins. Other things that will make it worse if you're deficient in magnesium, and most Americans are because they don't eat enough plant foods. That makes you more sensitive because the NMDA receptor, if it doesn't have, magnesium in that center blocking that receptor, blocking that calcium channel, more calcium gets in. Okay. Aluminum can decrease the amount of magnesium and its function. Aluminum can form a complex with MSG to increase its absorption across the blood-brain barrier, so it's bad. Soda pop, which comes in an aluminum can, bad. Also, the phosphate itself can deplete the amount of magnesium available to block the NMDA receptor. Excessive psychological stress is associated with a lowering of potassium and magnesium. That's bad, increasing sensitivity to excitotoxins. So like I said, soda pop's a disaster. You got the caffeine, which is an excitotoxin in and of itself. HG inhibits glucose uptake in astrocytes, so it'll decrease the energy function in the astrocytes. A high-fat diet is going to decrease insulin sensitivity. It's going to cause insulin resistance. We talked about that in previous lectures. Another thing I would talk about, I've talked about this in other lectures, my reading and studying of mitochondria inhibitors is they make excitotoxicity worse. My reading and study of circuit inhibitors, they make excitotoxicity worse. I also think caffeine's a disaster because it's not only an excitotoxin, it's also a vasoconstrictor. So I did all this additional study about nutrition and other toxins. And what I found is that, Blaylock is right, but there's 10 times worse things going on besides all the stuff Blaylock talks about. And this is why I meant that the brain is fragile and it's worth knowing about this stuff. And then you say to yourself, well, I don't got time. How can I study all this stuff and learn all this stuff? I don't have time for all this. And then I say, well, the answer is simple. Just be like Adam and Eve, but keep your indoor heating and plumbing, meaning avoid all the processed food. Avoid personal care products you don't need. Avoid anything that smells bad. If you just do that, you'll avoid most of this stuff. What that means is, like, let's say you have to work with smelly paint. You have to paint something. Well, ventilate that area really well. And if you have to paint, wait till summertime when you can open up the windows. Don't paint in the middle of the winter when it's cold outside and you can't open up the windows. Okay. Alcohol lowers body stores of magnesium, so it makes you more sensitive, more vulnerable to excitotoxicity. If you have a so-called energy crisis from prolonged fasting. So if you're going to break your fast, don't break it with junk food when you're eating all this MSG and your body's low on glucose and you might not be able to energize your ion pumps in your membranes to pump that calcium out of the cytoplasm of your neurons. What else? Just eating plant foods. You get what you need. You get fiber, so you make yourself have an intact blood-brain barrier. You get vitamin C, your antioxidants. You get your adequate sleep, the brain can clean itself and expel its waste products, the lymphatic system. Avoid all the other stimulants too, because they all just worsen this process. And Blaylock himself says, avoid all the excitotoxin foods. And it comes down to, how are you going to deal with this other than don't eat processed foods. Don't eat anything with more than one ingredient in it. So that's it. I thought that was kind of interesting. I hope you found that interesting and helpful.